This video is brought to you by MathGalaxy.com, and in this lesson we'll continue looking at SAT arithmetic number properties. And in this lesson we'll look at negative numbers and prime numbers, including factors, divisors, divisibility, multiples, etc. So looking at negative number problems, for example, if x is less than 0, which is greatest? Well, as always, we want to work with some specific numbers. So what if x is equal to negative 2? So that's negative 2. 2 times negative 2 is negative 4. 3 times negative 2, negative 6, and so on. Fairly easy problem, but always make sure you're giving them exactly what they want. Which is greatest? Well, negative 2 is less negative, so the answer is A. Okay, next question. The sum of 7 different integers is 0. What is the least number of these integers that must be positive? Okay, so a lot of information in here that could become confusing. So you want to break the problem down into pieces. We're summing 7 different integers. Okay, 1, 2, 3, 4, 5, 6, 7. It wants to know the least number, so it doesn't want to know the integers. It wants to know how many of them meet the condition that they must be positive. Well, what are the possibilities? Well, none of them could be positive, or all 7. So if we're looking for the least, well, we want to check, could none of them be positive? Okay, well, we can't make them all 0 because they have to be different. If they didn't have to be different, we could make them all 0. But we could at least use 1 0. That meets the condition that it's not positive. So since they have to be different, all the others have to be negative. If we're testing whether none of them could be positive. Okay, so, but they don't sum to 0. So we can't get by with none of them positive. So what's the next least one to check? Could there be 1 that's positive? Okay, so now to meet the sum criteria, so we have negatives 5, plus 4, negative 9, negative 12, negative 14, negative 15. So these sum to negative 15. So if we make that one positive one a positive 15, we meet all of their conditions. So again, always take an extra second to give them exactly what they want. If this was a grid in, you wouldn't grid in this because they're asking for the least number of these integers, which is 1. Okay, next, prime numbers, and that includes factoring, all divisors, greatest common factor, and least common multiple. First, what are the prime factors of 24? So for that, the easiest way is to do a factor tree. So you could factor 24 into 2 times 12, 12 into 2 times 6. So you want to start with the easiest prime divisors first. Start with 2, then 3, then 5. 6 you could factor into 2 and 3. Okay, so how many prime factors does 24 have? 4. How many distinct prime factors does 24 have? Distinct on the SAT means eliminate duplicates. So there are only 2 distinct prime factors. How many factors is a different concept, and factors are the same as divisors. I find the easiest way to do that is to do them in pairs, starting with 1. So 1 and its partner, 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't have any, and once this number is greater than its partner, you could stop because you've already checked the lower ones. So how many factors does 24 have? 2, 4, 6, 8. Okay. Next, x, y, z are prime numbers. How many factors does their product have? Well, let's be specific. Let's make x2, y3, z5. So they meet the conditions, they're prime numbers. So 2 times 3 is 6, times 5 is 30. So we could break that into 1 and 30, then 2 and 15, 3 and 10. 4 doesn't go into it. 5 goes into it 6 times. And 6 would just be reversing it. So there are 8 factors. If you did it algebraically, you'd have 1 and their product, and then you have them individually, x, y, and z, and then in pairs, x times y, x times z, and y times z. While we're on primes, how do you determine whether a number is prime? Let's say a number like 97. Well, you see if it's divisible by all the lower primes. To be prime, it has to be odd, so we don't have to worry about 2. Divisibility by 3. If the sum of the digits is divisible by 3, the number is divisible by 3. 9 plus 7 is 16, which is not divisible by 3. Okay, and you could always check by dividing. 3 goes into it about 32 and a fraction. Okay, next, prime 5. And the rule for 5, it has to end in 0 or 5. So it's not divisible by 5. Then 7. Well, you have to do the division. 7 into 97. 1. There's no rule for 7. 27. 4 sevens are 28. 3 sevens are 21. So that's not it then. 11. And so 7 goes into it 13. And some 11 goes into it. Well, 9 is too high, so it goes 8 and a fraction. And once you check the lower ones up until this is greater than its partner, you know you've checked all possibilities, so it's prime. But don't go just by looks. You have to check. So, for example, 91. So again, we don't have to check 2. Sum of the digits is 10, which is not divisible by 3. If you did division, it would be like 30 and a fraction. Doesn't end in 0 or 5, but 7 into 91 goes exactly 13 times. So it isn't prime because you could factor 91 into 7 times 13. So you always have to check. Next example. X is divisible by 3, y is divisible by 5. Which of the following is divisible by 15? So again, let's be concrete. X is divisible by 3, so let's make that 9. Y is divisible by 5, so let's make that 10. So x plus y, that's 19. Is that divisible by 15? No. X squared, 81, plus 10 is equal to 91. So that's not divisible by 15. 5 times 9 is 45. 3 times 10 is 30. So that's 75. So again, you'd want to be doing these on your calculators. So a quick division would see that it's divisible. by 15. Okay, 3 times x, which is 27, plus 5 times 10, 50. So that's 77. It's not divisible by 15. 2 times 9 is 18, plus 2 times 10 is 20, 38. And again, you're never going to see a problem quite like this, but the problems are going to be testing the basic concept. So what is the concept here? Divisibility. So x is divisible by 3. What does that mean? It means x has a factor of 3 in it, and some other integer, and y is divisible by 5. So y has a factor of 5 in it. Okay. So, for example, the first one is, well, 3 times some number plus some, and the integer. So 3 times some integer plus 5 times some integer. Is that going to be divisible by 15? No. Now let's go down, save a little time, look at C. So we're talking about 5 times x. Okay. So 5 times an integer that's divisible by 3 plus 3 times some integer that's divisible by 5. Is that divisible by 15? Well, this has a factor of 15 in it. This has a factor of 15 in it. So it's going to be divisible by 15. Next problem. Integers divisible by 4, 6, and 8 are also divisible by which of these? With divisibility, you want to be thinking in terms of prime factors. So you could factor 4 into 2 times 2, 6 into 2 times 3, and 8 into 2 times 2 times 2. Okay, so to be divisible by 4, a number needs to have 2 2's as factors. To be divisible by 6, it needs a 2 and a 3. Well, we already have a 2, we just need to add a 3. And to be divisible by 8, it needs 3 2's, so we need one more 2. There could be other factors in there, but it needs at least those. For example, to be divisible by 6, it needs the 2 and the 3. Okay, so now what about 15? To be divisible by 15, it needs a 3 and a 5. Well, it has a 3 but no 5, so that's not it. 24 we could factor into 2 times 12, and 12 into 2 times 6, and 6 into 2 times 3. Okay, well that looks like a possibility because we have everything we need. But just to make sure, let's look at 30. It factors into 3 times 10, and 10 into 2 times 5. So we need a 3, 2, and a 5. Well, no 5. 36, we could do a 6 times 6, which is equal to 2 times 3, and then another 2 times 3. So we need 2 2's, which we have, but 2 3's, which we don't have. And 48, well, we could do 6 times 8, which is equal to 2 times 3 times 3 more 2's. Okay, so we need 4 2's and a 3. We have a 3, but we only have 3 2's. So the only one that meets the condition is B. This was the second of 3 sessions reviewing SAT arithmetic number properties on negative numbers and prime numbers. But remember, there's no substitute for practice. So you should go into the SAT Blue Book and practice some of these problems. And thank you for listening.